Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a truly mind-blowing discovery. Two Grand Canyon-sized valleys on the far side of the moon formed in a mere 10 minutes. Incredible, right?
10 minutes? That's unbelievable. What caused such a dramatic event?
Exactly. The research points to a colossal impact, a massive object. We don't know exactly what, slamming into the moon near the South Pole, within the Schrödinger impact basin. The energy released was, get this, 1,200 to 2,200 times more powerful than the energy planned for excavating a second Panama Canal.
Wow, that's a lot of energy. So these canyons, Valles Schrödinger and Valles Planck, are essentially scars from this ancient impact?
Precisely. They're gigantic. Think Grand Canyon scale, but on the moon. The study used images and elevation data from NASA's Lunar Reconnaissance Orbiter to map this deep. Valles Schrödinger is 168 miles long and 1.7 miles deep. Valles Planck is even bigger, 174 miles long and 2.2 miles deep.
Amazing. And this all happened billions of years ago?
Yep, around 3.8 billion years ago. The study authors used impact cratering calculations to work out the velocities of the rocks and the size of the debris streams. It's like piecing together a cosmic jigsaw puzzle from billions of years in the past.
Fascinating. But how did they determine the time frame? Just 10 minutes.
That's the really impressive part. By analyzing the distances of the canyons from the impact point and the velocities of the ejected material, they were able to model the event. The calculations suggest the debris carved these canyons in an incredibly short time. It's a stark contrast to the Grand Canyon's formation, which took millions of years of water erosion.
So the moon's craters are like a preserved record of early solar system events, unlike Earth's, which have been eroded away?
Exactly. That's the key takeaway. Dr. David Kring, the lead author, emphasized this. Earth's geological processes have erased much of its early history. But the moon's surface retains this ancient record. This makes the Schrödinger Basin and its canyons incredibly valuable for understanding early solar system bombardment and its effects on both the moon and Earth.
I see. Interesting. But is this theory universally accepted? Are there any dissenting opinions?
Well, Noah Petro, a NASA project scientist, wasn't involved in the study, but he called it a nice hypothesis. He highlighted the study's connection of the canyons to a single impact point and the use of modern spacecraft data to reconstruct such an ancient event. He emphasized the excitement of peeling back the layers of time. So, while it's a hypothesis, it's a well-supported one based on strong evidence.
Got it. And what about future exploration? Will we be visiting these canyons soon?
Absolutely. The Schrödinger Basin is a prime target for future Artemis missions. Team Draper's lunar lander is scheduled to land there in 2026. Carrying seismometers to study the lunar interior. The potential for discovery is immense. Astronauts could potentially collect samples from up to 3 kilometers beneath the surface, providing unprecedented insights into the moon's early history.
Incredible. This is truly groundbreaking research. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for more fascinating discoveries. Goodbye.
Bye-bye.